so I'd like to go ahead and just hand the presentation over to Leslie and Mike. If you do need to contact us at any point here at ITEP, here's our contact information, and otherwise I will pass it over to you, Leslie and Mike.
Thanks very much, Christina. Can you hear us?
Yes, you sound great. We've got great audio from your end.
Okay, let's advance the slides. Okay, well, thank you very much. Again, this is Leslie Gentarosimi from EPA's Office of Air and Radiation in the Climate Change Division, and we are so excited to be able to share with you today this report that we've worked on for a long time. And I'm here with my co-presenter, Mike Colian, and he is one of the leaders of the effort of this report. I fit into this because I am the Climate Change Division's tribal coordinator, and so we work with ITEP to provide resources and trainings to help tribes understand the impacts of climate change, as well as plan for preparing and adapting to climate change. So I'm going to turn it over to Mike. He's going to the presentation, and then I'll jump in about midway through. Thanks.
All right. Thank you, Leslie. As she said, we're really glad to be here and excited to kind of take you through the report, give you a little more information about what's in it and what is available as far as the resource online. So just kind of jumping in and what we're going to talk about today, we're just going to go through the indicators report and its goals, what we're trying to accomplish, and sort of a little bit about motivation about how it was put together. We'll discuss some of the key findings and messages that we can summarize from the report. We'll preview several indicators, a good representative set from the report from all the different chapters, and then we'll also explore the website. I think that's a really good way for people to just peruse and drill down into each indicator, get the information they're looking for. They may not be looking for all of them, but just a specific few. And then we'll kind of open it up, I think, to some questions and answers, and hopefully we can address some of your concerns and issues. And we'd love to hear back from you and how useful this report is. So just a little bit about the goals of the report. The main driver here is to communicate. We're really looking to communicate the causes and causes and effects of climate change in an easy to understand way. So what is happening now? And indicators are a great way and really useful way of communicating that information. We're focused mainly on observed data, so measured observations. We're not including any future projections or modeled data in these indicators. Just sticking and drawing kind of a bright line at present and looking over the historical record and what instruments have been able to measure or what we've been able to observe over time. We're trying to show important trends that are relevant both to society, the environment, things that we care about, and also we hope that this report, pulling all of these indicators together in one place, helps inform existing and future climate-related programs. So this is sort of the background of why we put the report together. Incidentally, the 2012 report was released just in December, so fairly recently. It's a very current, well-vetted, authoritative report on these indicators. It updates the 2010 report that we released in April 2010, so we had a foundation to work from. We had a format and a consistency to work with for the indicators in the updated 2020 report. It consists of 5 chapters: greenhouse gas, weather, climate, oceans, snow and ice, and a chapter on society and ecosystems. So the 26 indicators in the report are spread across those 5 chapters. We came up with 3 completely new indicators for this edition of the report, one on snowfall, which Leslie will be talking about a little bit later. Actually, all 3 of these Leslie will be mentioning a little bit later in the talk. Nearly all of the indicators were updated with data that's become available since that initial 2010 report, and we expanded several indicators with additional metrics. So if an indicator is one indicator is temperature, we show 3 to 4 different graphs figures for temperature, and that's what I mean by metrics. The report relies on publicly available data, peer-reviewed data sets. We're really looking to other federal agencies. There's NOAA data that we use, NASA, USGS, CDC, other research institutions and organizations, universities. So we're really pulling from cool science literature and publicly available data that's out there. In addition, the report underwent an external peer review. So everything, all of the contents were reviewed. Specific indicator experts were reviewing those chapters and indicators that they had expertise in. So again, it's a really well-vetted resource. So just kind of to the basics of what is an indicator, and we really start with a basic kind of generic definition of what an indicator is, and it represents the state in certain environmental conditions over a given area and a specific time period. And this is important, and we start with this definition. Everybody seems to have their own unique definition for an indicator, but what really makes an indicator or an indicator that makes it into this report are the criteria that we use to select them. And so starting with that 2012 report and into the 2012 report, we use the same set of criteria. We have a process that evaluates each prospective indicator based on all of these things. We're looking for long-term trends over time. We're looking at indicators based on observed data. Again, there's no projection modeled data that we are considering here. We're looking at broad geographic coverage and it's well represented in the U.S. It is a national report, although we're including other indicators that have a global coverage. Just for context, there's also indicators that are less than national. There might be specific to the mountain region. But again, we're looking for this geographic coverage as possible. That comes from peer-reviewed data and published data sets where we can look at the documentation so that it's transparent, reproducible, objective. It has to have a relevance to climate change. These are climate change indicators. It has to be feasible to construct on an ongoing basis. So we're looking for indicators that continue to get data from. Somebody's collecting it over time. We can update it annually or whatever the frequency might be. And last but not least, we're really looking to communicate to the public as our base audience. It's also authoritative and speaks to many other audiences, but we're really trying to just make this easy to understand and straightforward. So here on slide 10, we just are sharing all of the indicators in the report spread across the different chapters, starting off with greenhouse gases, weather, climate, oceans, snow and ice, and ecosystems. in society. And we'll go through all of these, but we have a good representative set of indicators we'll be going through in just a moment on all of these, or many of these rather.
Hi, everyone. It looks like we lost.
Level
Okay.
is rising along much of the U.S. coastline over the past half century. The extent of Arctic sea ice has decreased markedly, with 2012 one of the lowest on record. And glaciers in the U.S. and worldwide are melting faster and losing mass. We're also seeing changes in ecosystems that are relevant for phenology, biological processes, and just other shifts. We see a lengthening of the growing season and the ragweed pollen season. Bird ranges have moved further north, and we'll see evidence of these in all three of those indicators in Leslie's portion. So we start off this story with greenhouse gases. And we know that in the U.S. and worldwide, greenhouse gas emissions are going up. And this is a significant driver to climate change. And we show U.S. greenhouse gas emissions and sinks by economic sector. We also show it by gas. We use EPA's, sorry, there's in the way here. So we use EPA's greenhouse gas emissions inventory as our primary emissions data source. And we also are showing, of course, global emissions. We show by economic sector and also by gas.
Mike, I'm sorry, if I can interrupt you for just a moment.
Leading atmospheric concentrations of greenhouse gases increasing over time. Here we're looking at carbon dioxide and showing the trend all the way back 650,000 years ago. You can see in the very left panel, dating back 650, using ice cores and various studies, reliable records. And then on the far right, you see the most recent time period. It's just expanding that out to give a little more perspective. But current global atmospheric concentrations of carbon dioxide are at unprecedented levels compared to thousands of years past. We show the same thing for methane and nitric oxide, as well as some other important greenhouse gases. So this particular indicator is 4 pages long, but just showing you a preview of carbon dioxide here. And jumping into weather and climate. Here we have U.S. global temperatures, and just the rate of change in U.S. temperatures over the past century, or more than the past century. And we see much of the U.S. experiencing increased rates of temperature change here. And worldwide, you see the similar pattern. In the right-hand graph, you have anomalies, and these anomalies is a departure from an observed value from a base. So these are indicating changes that are occurring over that entire across that entire time period. It's also measured satellites in the later of the period. These are lining up very well with land-based measurements. 2001 and 2010 was the warmest decade on record since these observations began. So we see clear evidence of warming temperatures. Another way on here is high and low temperatures, and we have an indicator that looks at a different perspective, a different part of the temperature data distribution. In the left-hand side, we're looking at data maximums and minimums, and the warmest 10% of those data sets, and you can see the trend over time is since the 1970s, 60s is increasing, and this is important, showing that these kind of extreme temperatures are occurring at a faster rate. There's less cooling off at night if the minimum stays high. And on the right-hand side, you see the record highs and lows for temperatures in the U.S. from 1950 to 2009. Over time, you can aggregate these records. This is a proportion of record highs to record lows, and you see a shift from the 1950s to present, almost a 2-to-1 ratio, where you're getting far more record highs than you are record lows. This is a slightly different perspective and sometimes easier to understand for people than anomalies from a baseline. So. This is U.S. global and global precipitation. The same sort of thing as with temperature. All the data comes from NOAA. This is total annual precipitation. And the rate of change in the U.S., you're also seeing much of the U.S. is increasing, but it's very variable. There's a lot of different areas that are also seeing decreases. Precipitation worldwide, you can see in the lower left, 1902 to present is these are anomalies again from the normal, and a lot of variability, but we're in general increased precipitation. We're also seeing heavy precipitation. We have an indicator looking at the extreme single-day events. And we see 8 of the top 10 years for extreme one-day events have occurred since 1990. So this graph is showing percent land area. So we're seeing the U.S., these one-day extreme precipitation events occurring over greater areas across the 48 states. For drought, we have a couple of metrics. We have one in the upper right showing average conditions. This is the Palmer Drought Severity Index, and is also showing the deviations from the normal, and showing really wet and dry periods for the nation. There isn't a significant directional trend here because it is for the nation, but we know that there are parts of the country that are in persistent drought or wet than dry. The lower left is the drought monitor, and this is the National Drought Mitigation Center puts this together, and there's different classifications for the U.S. over time. And so you have abnormally dry, moderate drought, severe drought, extreme drought, exceptional drought, and show the different classifications of land area for each year. Tropical cyclone activity is another indicator in the weather and climate chapter, where we're showing the number of hurricanes in the North Atlantic. And those are the top lines in the left graph. We're showing the count of hurricanes, and it's been adjusted because in earlier times we have the benefit of satellites and other aircraft that's used to measure these things, so it has been adjusted. But bringing forward to present, it's unnecessary to use that adjustment. In the green, we're showing the number of landfall hurricanes in the U.S., which is important to be tracking as well. And then on the right is the North Atlantic cyclone activity. This is more focused on storm frequency, speed, and duration. It has more emphasis on storm intensity, and we see this is very consistent with the science that these tropical cyclone activities are becoming more intense over time.
All right, well, I'm going to take over for Mike and talk a little bit about our oceans indicators. And these are important because the oceans and atmosphere are constantly interacting. They exchange energy, water, gases, particles. Changes in the ocean systems generally occur over much longer time periods than in the atmosphere. And so the trends that we find can persist for decades, centuries, or longer. And so for this reason, even if greenhouse gas emissions are stabilized tomorrow, it can take many more years, decades to centuries, for the oceans to adjust to changes in the atmosphere and the climate that have already occurred. So our first set of indicators for oceans are ocean heat. Oh, there we are. Ocean heat and ocean acidity. So the graph on the right shows that oceans have become warmer since 1955. These data come from 3 different analyses, independent analyses, by 3 different science agencies, one in the US, which is NOAA, Australia, and then Japan. So we're seeing a pretty clear trend towards higher temperatures in the oceans, although the rate of change can vary from year to year. And some of the influences that can change the year-to-year variability include volcanic eruptions and some of the recurring ocean atmosphere patterns, such as El Nino. And so this is important, or why it matters is that warmer waters can promote development of stronger storms in the tropics, which is what Mike was just talking about with your indicator. These can cause property damage, loss of life, and are definitely a big deal around the East Coast, at least. So ocean acidity is an important indicator because oceans, they can help to reduce climate change by storing 1/5 to 1/3 of carbon dioxide that human activities emit into the atmosphere. But these increasing levels of dissolved carbon that find their way into the ocean are actually changing the chemistry of the seawater, and they're making it more acidic. And we can measure this. Ocean acidity measurements that have been made over the past few decades have demonstrated that there is a decrease in pH. And so these graphs, you can see a slight downward trend in these graphs because they're measuring pH, which is the decrease. But that actually means is that there's an increase in acidity. And increasing acidity can reduce the availability of some types of minerals in the ocean, which makes it harder for certain organisms like corals and shellfish to build their skeletons and shells. So these types of effects could have substantial implications for biodiversity and ocean ecosystems. So our next indicator for oceans is level. And so it's not shown here in the graph, but we have paleoclimatic evidence that, for approximately 2,000 years, there have been little change in sea level. Global average sea level, however, rose throughout the 20th century, and the rate of change has accelerated in recent years. So when averaged over all the world's oceans, absolute sea level has increased at an average rate of 0.7 inches per year from 1880 to 2011. But then from 1993 to 2011, the average sea level rose at a rate of 0.11 to 0.13 inches per year. So this is roughly twice as fast as the long-term trend. And so this map here you see of the United States, the relative sea level rose along much of the U.S. coastline between 1960 and 2011. Particularly you see on the mid-Atlantic coast and parts of the Gulf Coast with those orange arrows. Some stations registered increases of more than 8 inches. So meanwhile, however, relative sea level fell at some locations in Alaska and the Pacific Northwest, because at those sites, even though absolute sea level has risen, the land elevation has risen more rapidly. So regional trends vary across the United States, and even in some places, you could say absolute sea level has decreased. And then this rise is not uniform because regional and local changes in land movement and long-term changes in coastal circulation patterns are also playing roles. So our next set of indicators has to deal with the snow and ice chapter. Arctic sea ice. The extent of area that's covered by Arctic sea ice is an important indicator of change in global climate because warmer air and water temperatures are reducing the amount of sea ice present. And it's important because sea ice is more reflective than liquid water. It plays a significant role in Earth's energy balance and helps to stabilize the Earth's climate. Sea ice keeps air in the polar regions cool by forming a barrier between the air above and the warmer water below. And so as the amount of sea ice decreases, the Arctic region's ability to stabilize the Earth's climate is reduced. And this can actually lead to what we think of as a feedback loop. You can have more absorption of solar energy, higher air temperatures, greater loss of sea ice. So the sea ice typically reaches its minimum thickness and extent in mid-September. So you see here the metric is called September average Arctic sea ice extent. When we measure, we have data stretching back to 1979 on this. So the ice starts expanding again after September. So September 2012 had the lowest sea ice extent on record, which was 49% below the average 1979 to 2000 average for that month. And this low sea ice extent was about an area 5 times the size of Texas lower than the historical average. So it's 1.3 million square miles lower than the average. And although the annual sea ice extent typically occurs in September, all months have shown a decreasing trend in sea ice over the past several decades, and the largest decreases have occurred in the summer and fall. Also, you can see in the small graph, the blue chart, that this depicts age of sea ice. And this is an important indicator of Arctic conditions because older sea ice is generally thicker and stronger than younger ice. And a loss of older sea ice would suggest that the Arctic is losing ice faster than it is accumulating it. And so see here the proportion of the sea ice that's 5 years or older, which is the darkest blue on the bottom of that graph, has declined dramatically over the recorded time period from more than 30% of September ice was more than 5 years old in the 80s. But now in 2012, it was only 4%. So a growing percentage of Arctic sea ice is only 1 or 2 years old. And so this young, thin Arctic ice makes it more vulnerable to further melting. So here's one of our new indicators, snowfall. Total snowfall has decreased in most parts of the country since widespread observations became available in 1930. So we took a look at these weather stations and found that 57% of stations measured show a decline in total snowfall. And so in addition to some of the precipitation trends that Mike talked about, climate change can also lead to changes in the type of precipitation. So we're seeing, a decline in total snowfall because more of the winter precipitation is falling as rain rather than snow. So more than 3/4 of the stations across the lower 48 states have experienced this decrease in the proportion of precipitation falling as snow. However, snowfall trends vary by region. Pacific Northwest has seen a decline both in total snowfall and the proportion falling as snow, but parts of the Midwest have experienced a decrease, particularly in terms of snow to precipitation ratio. Though a few regions have seen modest increases, including you see some near the Great Lakes areas that now receive more snow than they used to. Glaciers is a very important indicator because they provide a lot of services to communities and society. In many areas of the U.S., glaciers are a reliable source of drinking water. They fill the streams, particularly in times of extended drought and late in the summer season. The snowpack, as it melts away, is a very important source of freshwater runoff. And this runoff also can influence the ocean ecosystems. So these physical changes in the glaciers, whether they're growing, shrinking, advancing, receding, they provide a very visible evidence of changes in temperature and precipitation. And if glaciers lose more ice than they can accumulate through new snowfall, they ultimately are adding more water to the oceans, which contributes to the rise in sea level. The same changes on a much larger scale you may have heard about within the giant ice sheets that covered in Antarctica. These would have very big implications. But even the smaller glaciers, we see they tend to respond more quickly to climate change than the giant ice sheets, and they have added more water to the oceans than the ice sheets have in recent decades. So our indicator here is for 3 U.S. benchmark glaciers. In western Washington state, there's 1 benchmark glacier and then 2 in Alaska. And these U.S. benchmark glaciers have shown an overall decline in mass balance, that is how much ice they have, and since the 1960s. And then in recent years, you can see that acceleration in the rate of decline. These trends are consistent with glaciers observed, throughout. They're sort of representative, say, of Western U.S. Alaska glaciers and actually glaciers throughout the world. And so you see in the lower left graph, on average, glaciers worldwide have been losing mass since at least the 1970s, which, as we just said, is contributing to observed changes in sea level. So I just wanted to mention the next couple of indicators I'm going to present to you actually are an indication of shifts in the timing of certain events, such as life cycle events or seasonality type of shifts. And so just keep that in mind as we walk through these indicators, that these changes in timing are consistent with the climate trends that we've also observed over the same time period, such as increasing temperatures and changes in precipitation. So lake ice, the duration of lake ice cover, we've selected the lakes that you see here in the graphic because they've had these long-term records, reliable records dating back to 1850. So we can measure over this time period that the time that these lakes stay frozen has generally decreased. For most of the lakes, this indicator, the duration of ice cover has decreased at an average rate of 1 to 2 days per decade. So they're generally freezing later than they did in the past. And the thaw dates for most of these lakes also show a general trend toward earlier ice breakup in the spring. So it's a shift in the seasonality of this lake ice. And this is consistent with other studies. We took a look at a broad study of lakes and rivers throughout the northern hemisphere, and has that freeze dates have occurred later at an average rate of 5.8 days per 100 years, and thaw dates are also occurring at an average rate of 6.5 days per 100 years. And so the changes of ice cover on lakes and other bodies of water has pretty big implications for society, the economy, certainly things like shipping and transportation, power generation, fishing. All of those types of activities are dependent on, in some way, on ice or on the lakes. And so if there are, reductions in the ice cover on a large lake, like one of the Great Lakes, then this could have big implications for different seasons that things occur. And so an interesting example that Mike found was a recent article about one of the national parks. It's called Apostle Islands National Lakeshore. It's in Wisconsin on the Lake Superior coast. And one of the main attractions of this lake is a natural phenomenon that occurs in the winter, that the water kind of freezes in caves along the lake edge, and that they form these spectacular ice sculptures. And this is one of the most things about this park. But you have to hike over the lake ice in order to go there. And since 2009, it hasn't been safe to you haven't been able to see any of the ice sculptures because of the breakup of lake ice. It hasn't been thick enough to be able to cross. So it's an interesting story that kind of highlights some of the indicators that we've been measuring as well. So we're going to move on to the last chapter of the indicator report, which is society and ecosystems. And then the first indicator in this chapter is stream flow, newest indicators. It includes 3 metrics, which is high and low stream flows, which are not pictured here. But the one I wanted to focus on was the time winter-spring runoff. This stream flow is actually a measure of the amount of water carried in a river or stream, and this can directly influence supplies of drinking water, the amount of water that's available for crop irrigation, for generating electricity, or other types of needs. And in addition, many animals, ecosystems depend on the stream flow for habitat. So this is a very important indicator. And we've been seeing that climate change can affect stream flow through changes in the amount of snowpack. We kind of talked about snowfall earlier, but it's resulting in earlier spring melting, and these can alter the size and timing of peak stream flows. More precipitation is expected to cause higher average stream flow in some places, while heavier storms, such as the heavy precipitation indicator that Mike talked about, could lead to larger peak flows in streams, or droughts that we also talked about earlier could also reduce the stream flow in certain areas. But we see here in the shift in timing is that 60% of the streams measured show that winter-spring runoff is happening more than 5 days earlier than it did in the past. So they kind of indicates, it could have implications for how we store our water and how we manage reservoirs, and just is another indication of that shift that we were talking about. The length of the growing season, average length of the growing season in the lower 48 states, has increased by about 2 weeks since the beginning of the 20th century. And particularly over the last 30 years, we've seen a large and steady increase in this growing season. The figure 1 on the right. And then interestingly, for the U.S., the length of the growing season has increased more rapidly in the west than in the east. And so you can see that depicted in the lower left graph. We also, what's not pictured here is that the final spring frost is now occurring earlier than at any point since 1895, and the first fall frosts are arriving later. Since 1980, the last spring frost has occurred as an average of about 3 days earlier than the long-term average, and the first fall frost occurring about 2 days later. So the growing season is just an important indicator overall because it helps influence which types of crops can be grown in an area, since some crops require longer growing seasons, others mature more rapidly. Depending on the region of the U.S. and the climate in that region, the growing season can be influenced by the air temperature, the number of frost days, the rainfall, or the daylight hours. So these types of changes can either yield, positive or negative effects. But we can see some disruption of the types of crops that are grown that could encourage invasive species or weed growth, or increase the demand for irrigation. So these are some of the considerations for changes in the growing season. Bird wintering ranges. You might wonder, why are you choosing that indicator? So changes in climate can affect ecosystems by influencing animal behavior and distribution. And so we focus on birds because we feel they're a particularly good indicator of environmental change. Bird species are adapted to certain habitats, their food sources, and temperature ranges. And so when we, have data sets like the National Audubon Society have data sets, because there are lots of bird enthusiasts out there. They're easy to identify and count. So there's just a lot of scientific information and knowledge about their distribution and abundance. And so we can draw on that data to see what the trends are. And so we've found, as you can see in these two graphs, the center of abundance for 305 widespread North American bird species. And by center of abundance, this is defined as a point on a map that represents the middle of each species distribution. So if a whole population of birds were to shift generally northward, you could see the center of abundance also shifting northward. So, and that's exactly what we're doing here. Between 1966 and 2005, the average center of abundance is moving both northward and inward from the coast. About 35 miles on average, and bird ranges are also moving further inland. These types of trends are closely related to winter temperatures, which we've seen increasing. So for important new indicator that we have here for human health, climate change impacts on human health, is the ragweed pollen season. And this is important because more than half of Americans have at least one allergy. And these allergies are a major public health concern, with hay fever, which is, congestion, runny nose, itchy eyes, can account for more than 13 million visits to physicians' offices and medical facilities every year. So we focused on one of the most common environmental allergens, which is ragweed. An estimated 26% of all Americans are sensitive to ragweed. And these plants mature in midsummer and generate pollen at that time. And the pollen season usually peaks in late summer and early fall. So climate change, warmer spring temperatures can cause some plants to start producing pollen earlier, while warmer fall temperatures extend the growing season for plants in general, like we already saw with the length of growing season indicator, but this also has specific implications for ragweed and other allergens. So the graph here shows that, or the figure here, that since 1995, ragweed pollen season has grown longer at 8 of the 10 locations studied. And so the increase is a really sharp trend going from south to north. The ragweed season increased by 24 days in Fargo, North Dakota, and 26 days in Saskatchewan and Canada. And this trend is consistent with other observations showing that climate is changing more rapidly at higher latitudes. And so these trends are strongly related to changes in the length of the frost-free season and the timing of the first fall frost. Finally, we wanted to highlight for you our heat-related deaths indicator, which is an important human health indicator related to those extremes of temperatures, the highs that Mike was talking about in the Weather and Climate chapter. So we can see in the data that over the past 3 decades, more than 7,000 Americans were reported to have died as a direct result of heat-related illness. And some of the logical measurement for how you get at this impact on human health from extreme heat, because it's a well-documented health impact in the scientific literature, is to count death certificates where the physician actually notes that heat was the underlying cause of death. And so from this data from 1979 to 2009, the death rate as a direct result of exposure to heat was about 0.5 deaths per million population. You can see spikes in certain years. And one of those, case study examples that is shown in the bottom graph is the 1995 heat wave in Chicago. You can see daily deaths has that spike during the extreme heat event. But the data also shows that there were hundreds more deaths than were actually reported as heat-related on death certificates. So this type of indicator just shows that sometimes it doesn't tell the full story. It's important to have indicators like these to track what's going on and try to improve the types of indicators and the data that we can pull from over time. One of our goals. And this actually just shows a 2-page spread from our actual report. The layout of the hard copy report itself has background information on each indicator. It highlights the key points, has some notes about the indicator and data sources and links, and includes all the figures that we've just been going through with you. I also want to mention that we focused a lot on this 2012 report on having an enhanced online presence. So our website's listed here at gov/climate-change/indicators, and Mike's going to be walking through sort of a quick tour of that website. But on our website, we have printer-friendly PDFs with all the text and figures. We have downloadable figures and graphics. If you want to use any of the information, you are free to use it. We definitely encourage everybody to spread the word about all of our indicators. We have a highlights brochure, which kind of gives a nice brief summary overview of the report and the different indicators and chapters. Easy to share if you have an event. Also, details on our methods and the data for each indicator are provided in technical documentation. It's available for download in its entirety, or you can download just the technical information for whichever indicator you're most interested in. So we'll show you where to find that. I also just wanted to give a quick summary about how the indicators are being used. So we have through our website, you can request a hard copy or multiple hard copies. We have a limited number, but the tribes that have requested copies of the report include some of the ones listed here. And we ask, when people request reports, we ask them to tell us, how are you going to use it? So the reported use by tribes include lending out reports, public outreach and education. They've been featured at Earth Day events, which highlight climate change and explain to the community how local climate impacts, what people can do about it. They've been used to inform tribal management. And then other organizations, non-tribal organizations, have used them to inform development of a local health adaptation plan. They've been used to assist in developing monitoring strategies for climate change. And so I'm sure people on the phone or on the webinar also have ideas or have maybe have already used the indicators report, and we'd love to hear more about how you think it's most able to be used and how it can support types of work that you're doing. And so what's for EPA indicators? Well, we definitely want to know what we're doing. We want to update and expand upon the current set of indicators. We'll be pursuing new options, and work is already underway to do that. So we may even sort of highlight issues in particular regions by being more regional indicator, or sort of delving down further into things like health. So we'll also continue to engage with other important indicators efforts that are ongoing with different organizations. For example, the U.S. Global Change Research Program, which actually is going to be featured in, I think, the next webinar in this series. They are also developing an indicator system, which is slightly different, but will complement the efforts that we're doing. So we'll continue to be involved in all of those things. So I think now we'll try to pull up the website really quickly. I only have, 3 minutes.
Sorry, this is Mike. Just mention real quickly before we get off this slide here, if you're interested in a report, a hard copy report or the brochure, you can just contact us at this mail-in email address right here, climateindicators@epa.gov. Just let us know what the report you're interested in, which would be or did we provide the EPA number? If you say Climate Change Indicators Report and how many copies you would like, this is free. So feel free to contact us at that email address.
Yeah, and here are our personal email addresses, which will be available to you later on ITEP's website if you need to get in contact.
Okay, so this is just the front homepage here of the indicators effort. At the top are the green tabs, and you can just kind of hover over these, and you'll see which indicators are in each chapter. You can then go down to a specific one, click on it. It'll pull up the graph as a default. But you'll see there are other graphs that are in this indicator are here below, and you can just click on that if you'd like to see the map. So these are the actual graphics that are in the report. You can get the same information that you're getting in the report for the key points, the background, about the indicator by over here on the left, these accordion devices. So all of this key information is available, explaining how it was derived, where the data sources are, a few notes on that indicator. And a real key piece of information here is the technical documentation. So we've reserved a lot of the really complex details, the documentation to a separate document, which you can get to by clicking here on this PDF. It'll take you to a separate document that explains in much more detail about the indicator. So you can scroll through each of the chapters and find the information you're looking for. And there's also, I'm going to go back to the home page really quickly. If you were interested in getting the entire report, it is at this page here, the Learn More box, and you can get the full report in PDF or any part of it that you wanted, any chapter. At this page is sort of our download page. And then one other feature I wanted to show you really quickly is, let's go to weather, climate, highs and lows. If you wanted the actual graphic, because sometimes people are interested in that image, to save it, put it in a PowerPoint or use it in some other fashion, you can do that. You can click here, print it, save it. So it's just another feature that we've added to provide more accessibility to each indicator.
Okay. Is that it?
Yeah, I think we'll just trying to get back to the main page there. But yeah, that's just wanted to kind of briefly show you how to navigate through the indicators here.
Okay, I think we have 15 minutes left for question and answer period. Christina?
Hi there, Leslie. Can you hear me?
Yes, I can.
Excellent. Okay. So we actually had some questions that were submitted during the registration process, and a couple of them seem like they would be pertinent to large segments of the audience that are with us here today. We had obviously a couple of funding questions regarding how to add climate change monitoring to existing air projects, which maybe I'll encourage individuals to follow up with you on. But one question that came up for several folks was, what is the best way to track climate change indicators from sort of a technological standpoint? In other words, if you have an existing air quality program, for example, how can tribes and other folks contribute to the data repository that exists on climate change indicators?
Okay, so can you hear us?
Yes.
Okay. Yeah, this report relies on, very little of it actually comes from EPA, comes from all different agencies and different sources of people that are collecting this data. I just think at the state level, local level, is where a lot of these programs, climate mitigation programs, adaptation programs, are happening, and that's where you're going to want to feed the information into. I think this national report provides kind of the perspective at that level, but we really need to drill down with that information. So if you're collecting air quality data for your state, for a particular region, just make sure it's accessible, it's available, well documented. I think for changes in climate, we're interested in just the accessibility and transparency of it, and it will inevitably get pulled into kind of centralized databases that are out there for this information.
Okay, great. Thanks so much, Mike. It looks like we actually have a question that was specific to the presentation. Somebody here is just looking for some clarification. And on that note, if anybody in the audience has any questions for Mike or Leslie specifically, please feel free to use this chat box function. But this looks like a question regarding the precipitation record. It says that it sounded as if there are record precipitation patterns taking place and record, it's just over here in this chat box, and record drought at the same time. And shouldn't those events be mutually exclusive? Can you speak to that?
Yeah, so kind of going back to the temperature or the precipitation record, we're showing a rate of change over 100 years. So a really long-term rate of change. Drought conditions exist, are ongoing, are constant. They're in various parts of the country, but we're just looking at a long-term average and a change from that average with this U.S. and global precipitation. So you can have both kind of coexisting. You can have drier periods or drier areas in the Southwest, where in the Northeast you're getting increases in precipitation and increases in heavy precipitation. So the two sort of can coexist. And this one that's looking at the rate of precipitation is a very long-term kind of trend.
Okay, great. Let's see. Okay, so Mike and Leslie, I'm not certain if you can see, it looks like some of these questions are actually just directed at me, so I'll convey them to you. So this is actually about more along the lines of climate change communication, and the question is how to convey the severity of climate change without overwhelming, specifically to youth, and I would probably expand that to community members as a whole without overwhelming them.
Leslie, take a shot at that, and then I can.
Sure. Well, I think that a part of it is just being in addition to presenting the data as as sort of we go through this process of collecting and verifying and having data that is well vetted, peer reviewed, sound, and so it's important to present that as it is, as what the science is telling us. But I also think that it can be coupled with messages that are more on sort of proactive messages. So messages that tell people how they can, play a role in either helping to reduce climate change through sort of mitigation actions and energy efficiency type of programs to reduce our impact on the climate, or on the adaptation side is to be prepared for changes that are going to happen and to think about it in terms of what can I do to just be knowledgeable and understand what types of impacts likely to occur, and then to think about different strategies for adaptation and preparation for change. And so it's the coupling of what does the science tell us, and then I agree that it's sort of difficult to not get a little bit depressed when you see all of these changes that are happening, but there are efforts underway to sort of focus on the sorts of adaptation strategies that we can take to sort of minimize and prepare for impacts. And so it's definitely an area where we can all take action and try to address change in those ways.
Great. Well, it looks like we got one more question here, and I'll just read it to you both. It actually pertains to sort of the development of these indicator reports and how we relate to our neighbors to the south. So this question asks whether or not whether there's any plan in place to actually extend the indicators report further south into northern Mexico. I would suspect that the answer is no, given that you're federally funded through the states, but is there any kind of partnership that's currently taking place between the U.S. and Mexico looking at some of these climate change indicators and how they might impact on both sides of the border?
Yeah, not specifically. I think as you sort of alluded to, that we are focused on the U.S. Most of the kind of federal agencies have their measurement and observations that are U.S.-based. A lot of the global perspective of the indicators would cover North America, would cover other parts of the planet, which is totally important when you're considering these changes. But we haven't really, not this effort in particular, have we worked with either Mexico or Canada, but I think there are other efforts that do bring in those countries in sort of a North American collective way for climate programs. But for these indicators, we haven't seen that. I don't suspect that Mexico would have the infrastructure that we had in the U.S. as far as long-term measurements, but that doesn't mean that there isn't a starting point somewhere. And I think that's probably another reason why it's just been held separate.
All right, great. Well, it looks like that covers all of our questions at this point. Thank you both so much for your time and for sharing your expertise with us. As I mentioned before, we're going to be offering a recording of this webinar along with the PowerPoint slides on the ITEP website, and we'll be sending out an email with the URL information and everything once that's actually up and live on our site. Thank you again both so much.
Thank you.
Thank you.
So that concludes this webinar. Thank you everyone for joining.